Welcome to our 106 project presentation. My name is Olga.
I'm Chiu Tsang.
I'm Anthony.
And our team name is the Smart Locker. We did this project to prevent drunk driving, since it is a big issue in the US. We solved this problem by creating a smart locker that would lock the keys of the user before having dinner in a restaurant, and it would detect the alcohol level in their breath after dining, and if there is alcohol detected, the keys of their cars would stay locked in the locker room, therefore preventing drunk driving. And now Chun is gonna talk about the mechanical design.
For the mechanical design, here's the locker made of wood. There are two doors. They are both with the handle and the hinges. The left-hand side door is for the key locker, so you can put the key inside on it. And the right-hand side is for the alcohol sensor. But as you see, the door opener is smaller, so you are unable to try to attempt to get your key when you are taking the alcohol test. For the inside, the motor are installed next of the two doors. They both working as a lock. As you see, if they are locked, you are unable to open the door. When it's unlocked, the motor side will comes out, so you can open the door easily. And here is installed a platform for the alcohol sensor, so the alcohol sensor was also installed inside. Going back to the outside. On top, this is the LED screen showing the information. For example, you have to enter your PIN, and underneath is a keyboard. You can enter the four digits of PIN. Now, owner is going to introduce the electrical part.
For the electrical design, I will go over the main components and their electrical connection. First, we use the Raspberry Pi Pico microcontroller as the primary means for controlling the operation of the system, which was plugged into the computer using a USB cable. And the Pico was used to power the components. In the following diagram, done on freezing, we can see that the electrical connections that are needed for the project. On the top left side, the keypad sensor is connected to the first 8 GPIO pins on the Pico. Below, we can see the OLED display connected to pin 16 and 17, and also connected to 3.3 volts and ground. On the top right side of the Pico, we can see the alcohol sensor MQ3 connected to pin 26 on the Pico and connected to VBus, powering 5 volts and connected to ground. In the middle, we have used the breadboard to facilitate connections. Below the breadboard, we can see the activators that we used for the project. We used 2 servo motors that are connected to pins 24 and 25 and are connected to 5 volts and ground. And now Anthony will talk about the project demo and show you how it works.
So for this project, I was in charge of the pin pad and making the main code, and I'll be showing you guys the demo for the code. So in the first state, all of the doors are going to open, and it's going to ask us to enter a 4-digit pin. So we could choose whatever we want. So let's just choose something simple. And once we choose a 4-digit pin, it's going to be code created. It's going to move on to the next state, where we can put all of our items into the box. So our keys, and it's going to have a 10-second timer before the door closes. And there the door locks, and now we can move on to the test state, where we could check for our alcohol level. So in the first scenario, if you don't breathe into it, it's just going to say no breath detected, and it's going to go back to the test state to try to detect a breath again. So it says try again, no breath detected. Now this time, let's breathe into it. It detected our breath. It said thanks, drive safe. We can now close the door, and the door is going to lock. And now we're going to go into our release state where we have to guess our pin. So I'm just going to put in the wrong pin just to see what it says. It says wrong pin, try again. Now we put in the correct pin that we chose. Code is correct, and now we're going to move to the release state The door is open. Now we can take out our items. Okay. So another scenario that we have for our test state is if you're drunk. Obviously, if you're too drunk to drive, it's not going to open the door. So instead of alcohol, we're going to use hand sanitizer for this test. And then the value is too high and it says don't drive drunk. And then it's not going to open the door. Okay, that's it. So for this project, something that I learned was properly choosing the right components. So when we initially had this idea, we were going to use a fingerprint sensor instead of a keypad. But as it turned out, the fingerprint sensor wasn't really compatible with our Raspberry Pi microcontroller. So we had to choose the keypad instead.
In this project, I mostly contribute in doing the code and installation of the motor, as well as design the lock mechanism of the locker. From the project, I learned that is, even though sometimes when you are doing the simulation or just coding a single component is correct, when each component, for example, motors, pin, LED coming together as a whole product, you probably need a lot of more modification, or it's not always success for the first trial. You have to do a lot of stuff to modify and finally get the product done.
So for this project, I wrote the code for the OLED display and the MQ3 alcohol sensor. I also created the freezing electrical diagram, and I made the SolidWorks model. For the locker, we all cut some wood together, and with Anthony, we set up the doors, hinges, and doorknobs. I also added a finishing oil coat to the wood to make it look nicer. In this project, I learned how to integrate software and hardware together, and my most challenging learning experience here was learning how the MQ3 sensor works. The way it works is that it reacts with the heated element in the MQ3 sensor, and it changes its resistance. This change in resistance is measured by the pico and as an analog voltage, and then is used to determine the quantity of alcohol in the user's breath. And then I learned to use those values to set a threshold value for when the alcohol is detected. During this project, I applied knowledge learned in class, such as defining functions and importing libraries into Tony, as well as the time.tix function on MicroPython.
The strongest school is that you get hit with clouds later, basically, and then like, oh, well,
Cool.
shit.
That's fair, that's fair. You hear that lead? My sausage? No, just said that's obviously just the door. Yeah. What did you ask for? I always asked for one thing, I'll eat two, so but like, I'm not eating more than that, so don't think you waste it.
Oh, there it is. Oh my god, it's shaped that it actually works.
The phone?
This is the most game shit I've ever made. I have 4 months in the diamond. This is like ungodly unoptimized.